Welcome back, everyone. Get ready to dive into a world millions of years in the making with creatures that are straight out of a prehistoric fantasy novel. We're talking Barbara Felidae, those incredible false saber-toothed cats. But why the nickname? Well, that's just one of the mysteries we're going to tackle today, right?
Absolutely. And it's a mystery that goes to the heart of evolution and classification.
Exactly. We've got articles, research, all sorts of goodies to dig into. So let's get started. What exactly were these Barbarophilidae and when did they prowl the planet?
Well, picture this, the Miocene epoch, somewhere between 20 and 9 million years ago. That's a seriously long time. And during this epoch, these diverse carnivores roamed across North America, Eurasia, and Africa. They're called Barbarophilidae, and as you mentioned, they had these super cool elongated canines, much like the famous saber-toothed cats. But, and here's the twist, they weren't actually closely related to them, hence the nickname false saber-toothed cats.
Okay, so not just hanging out in one corner of the world, but where did their story begin? Was there a kind of Barbarophilidae Central, a place where they first popped up?
Their earliest fossils, the ones that give us the first clues, are found in early Miocene Africa. But here's the thing, they didn't just stay put.
Oh, they were adventurers.
They were. A land bridge opened up connecting Africa and Eurasia, and the Barbarifellidae, well, they took full advantage, migrating from Africa to Europe. And not just once, we're talking at least 3 separate migrations.
3 times, wow. What would make them undertake those journeys?
It was probably a whole mix of things. Climate change, maybe the availability of prey shifted, even competition with other predators. All these things can push animal populations to, well, find greener pastures, so to speak.
Makes sense. And it wasn't just a simple move, right? I mean, traveling like that over such vast distances in time, it must have spurred some serious evolutionary changes.
Exactly, you're spot on. In fact, one genus, Sansanosmylus, actually evolved in Europe, showing how these migrations directly led to diversification.
Incredible. Okay, they're spreading across continents, evolving along the way. But we keep coming back to this false saber-tooth thing. If they're not true saber-toothed cats, then where do they actually fit in on the evolutionary tree?
Ah, that's the big question, isn't it? The classification conundrum. And it's a story of changing branches, ongoing debate, really showing just how dynamic paleontology can be. Initially, scientists placed Barbarophilidae within the subfamily Machaerodontidae, right alongside the true saber-toothed cats. I mean, it seemed like a perfect fit, those teeth, those canines. Hard to argue with that.
Right, it seems pretty logical at first glance, but I'm guessing it wasn't quite that simple.
You got it. As researchers dug deeper, analyzing their anatomy in more detail, some differences started to emerge.
So what kind of differences are we talking about?
Well, enough to suggest a different relationship altogether. Some studies started proposing that they belonged to the Neuravidae family, a group of extinct carnivores that also had those saber-tooth-like features but were distinct from the true saber-toothed cats.
Okay, so they got shifted to a different branch of the family tree, so to speak. Were there specific features, that pointed to this Nimravid connection?
Absolutely. And as research progressed, focusing on things like skull features and overall body structure, a new argument emerged. This one suggested a connection to the Felidae family, the one that includes all our modern cats like lions, tigers, even our house cats. And that's really where that nickname, false saber-toothed cats, really took hold.
Wow, closer to lions and tigers than to that classic saber-tooth image. So does that mean the classification debate is settled? Or are there more twists and turns in this evolutionary tale?
Just when we thought we had them figured out, a new discovery threw a wrench into the works.
Oh, what happened?
A new genus, Orientsmylus lupanensis, was discovered in China. And its skull structure, well, it suggested a closer relationship back to the nimbrifids.
Wow, so the debate continues. It's incredible how a single fossil can really shake things up. It really shows how science is always evolving, always refining what we know.
Exactly. Every new discovery has the potential to reshape our understanding. And this back and forth, this classification debate, really highlights the challenges and the excitement of studying ancient life.
Speaking of excitement, let's meet some of these false saber-toothed cats up close and personal. Millions of years of evolution, multiple migrations. I imagine there's quite a bit of diversity within the Barbarophilidae family. What are some of the standouts, the members of this group that really grab your attention?
Oh, there are a few. There's Barbara Felidae, the North American representative, showing just how far they traveled. And then, of course, Sansanosmylus, the one that evolved in Europe, highlighting how those migrations could drive evolution.
Right, those names are already sticking with me. I bet there are more, though, right? Give us a little more insight into this fascinating family.
Of course, there's Afrosmylus, hailing from Africa, as the name suggests. And then there's Prosansanosmylus, a bit of a mouthful, but a great example of their diversity.
These names are incredible. They sound like something out of a fantasy novel, but I have a feeling there's at least one more with a name that really jumps out, right?
Oh, absolutely. Get ready for this one. Vampirictus.
Vampirictus, that definitely sparks the imagination. Was this a prehistoric vampire cat?
Not quite a vampire, but the name is certainly fitting. It actually translates to weasel.
A weasel. Okay, now I have to know more. What earned it such a dramatic name?
Unfortunately, we only have a few fossil pieces of Vampirictus, but what we do know is that it was relatively small, maybe the size of a domestic cat. And while its teeth weren't as elongated as some other Barbara Felidae, they were still pretty sharp and pointed.
So maybe not a bloodsucker, but definitely a formidable predator for its size. It's amazing how much variety there was in this family. From lion size to weasel size, they really cover the spectrum.
You said it, and that diversity is reflected not just in their size, but in their adaptations and lifestyles as well. Each genus, each species within Barbara Felidae had its own unique features, helping it thrive in different environments and hunt different prey. It's a real testament to the power of evolution to create such an amazing array of forms and functions.
So we have these incredible creatures evolving over millions of years, migrating across continents, diversifying into all sorts of forms, even sporting names that sound like they're straight out of mythology. But what were some of the key characteristics that made them stand out from other prehistoric predators that really set them apart?
Well, one thing that really jumps out is the range of sizes we find within the family. Some, like that Vampirictus we talked about, were pretty small, like a lynx. And then you had species like Barbarophilus in North America, which could rival a lion in size.
Wow, so a real variety in stature. Did their hunting strategies change based on their size? I mean, I can't imagine a tiny Vampirictus taking down the same prey as a massive Barbarophilus.
You're right, their adaptations probably varied based on their size, habitat, and the prey they were after. But one thing they all shared, of course, were those fascinating saber-tooth-like canines. But here's another twist. Unlike true saber-toothed cats, their canines were often serrated like a steak knife.
Serrated teeth. That sounds terrifying and probably really effective for hunting. How did they actually use those teeth to take down prey? Was it a quick, precise attack or more of a brute force thing?
That's a question that's kept paleontologists busy for a long time. Based on what we see in their skulls and the wear patterns on those teeth, scientists believe they relied on powerful bite, probably aiming for the neck or throat of their prey.
So more about precision than brute force. Interesting. But what about their overall hunting style? Were they solitary ambush predators, or did they hunt in packs, more like wolves? Did their size play a role there?
It's a fascinating question, and there's still some debate going on. Some scientists think their robust build and those strong limbs suggest they were active pursuit predators, chasing down their meals. But others argue that their relatively short legs might have made sustained running a challenge. Maybe they were more about stealth and ambush, like some big cats we see today.
So a range of possible hunting styles, each adapted to their specific environment and the prey they were hunting. It seems like we still have a lot to learn about these creatures.
Absolutely. Every fossil we find, every study, brings us closer to understanding their behavior, their place in the world, their story in the grand scheme of evolution. It really is a captivating puzzle, you know? And speaking of puzzles, one of the big ones with Barbara Felidae is, well, their extinction. They were successful for millions of years, but eventually they vanished. So the question is, why? What happened?
That's a great point. They were around for so long. What could have led to their demise after all that success, all that adaptation?
Well, it's probably not a single, simple answer. It's likely a combination of factors. Much like those pressures that might have driven those migrations we talked about, climate change is definitely up there, a strong contender. We know that the climate fluctuated quite a bit during the Miocene, and those shifts could have easily disrupted their habitat, messed with their food sources, thrown things out of whack.
So even though they were masters of adaptation, even they had their limits.
Exactly. There's only so much change an annex can handle. And on top of that, you have to factor in the competition. The Miocene was a time of, well, a lot of turnover in the fauna. New predators were emerging, all vying for the same resources. So it's possible that Barbara Felidae just faced increasing pressure from these other carnivores.
A changing world, new competitors on the scene. It's like a whole prehistoric drama playing out. But even though they're gone, they're fossils, they still have a lot to teach us, don't they?
Absolutely. Studying extinct animals like Barbara Felidae isn't just about looking back, it's about understanding the bigger picture. They give us these incredible insights into how animals interact with their environments, how those relationships change over time.
It's like a window into deep time, getting a glimpse of what shaped life on our planet.
Precisely. And one of the things that makes Barbara Felidae so fascinating, particularly this whole debate about their classification, it really highlights how science itself works. It shows us that science isn't about having all the answers right from the start. It's about asking questions, constantly reevaluating, refining our understanding as new evidence comes up.
I love that. It reminds us that science is always evolving, always open to new discoveries, new interpretations.
Exactly, and those new discoveries, they can come from the most unexpected places. Remember that new genus we mentioned, Orientsmylus lupanensis? Finding it in China, a place we didn't really associate with Barbara Felidae fossils before, well, it really changed how we view their distribution, their history.
It's amazing to think that there are still fossils out there just waiting to be discovered, maybe holding the key to whole new chapters in the Barbara Felidae story.
There's always something new to uncover, right? And each new discovery adds to the richness, the complexity of their tale. But, even beyond that classification debate, what I find really captivating is that Barbara Felidae, they occupied this really unique position in the evolution of carnivores. They weren't true saber-tooths, but they weren't exactly like modern cats either. They represent this distinct lineage, showing this fascinating mix of features.
It's like they're filling in a gap in our understanding, giving us a glimpse of this unique pathway that eventually led to the amazing diversity of predators we see today. But with all the focus on their anatomy, their classification, I'm curious, what about their behavior? How did these creatures interact with their world, with each other?
Behavior. Now that's the question that really gets the imagination going. It's incredibly difficult, to reconstruct how extinct animals behaved. But we can use different clues, make some educated guesses. For instance, we can look at the size and shape of their brains, as we can see from their skulls.
So the size and shape of their brain case, that can give us hints about their intelligence, maybe even social behavior.
Exactly. Some studies suggest Barbara Felidae might have had relatively large brains for their body size, which is fascinating. It hints at a potentially higher level of cognitive ability. And it makes you wonder, what did those abilities entail?
It really does. It opens up all these possibilities, doesn't it? Did they have complex social structures, unique ways of communicating, even problem-solving skills beyond what we might expect from a prehistoric predator?
Those are all fantastic questions. And, we can also look for clues in their skeletal features. For example, if we see sexually dimorphic features, meaning differences between males and females like size or canine length, that suggests, well, potentially complex mating rituals, social dynamics.
So interesting. Even though we can't observe them directly, we can still find clues about their social lives, their behaviors, like we're detectives uncovering these hidden stories in their bones.
Precisely. And as we keep finding more fossils, refining how we analyze them, who knows what other secrets about their behavior we'll find. It's a journey of discovery, and it's full of potential.
It's amazing how much we can still learn from these fossils, even though, Barbara Felidae have been extinct for millions of years.
It really shows how much the fossil record can teach us, right? These remnants, these pieces of ancient life, they give us glimpses into worlds that are long gone, and they help us, well, put together this incredible story of evolution.
And speaking of stories, the Barbara Felidae story, it's got its share of twists and turns, especially when it comes to classifying them.
Oh, absolutely. It just goes to show that science is a process. It's always evolving, always changing as we find new evidence. The debate about whether they're closer to true saber-toothed cats or nimmervids or even our modern felids, it really highlights that.
It shows just how dynamic paleontology is, how much there is to discover. But even with those classification questions still hanging out there, there's just so much to appreciate about these false saber-toothed cats. They thrived for over 11 million years, adapted to all sorts of environments, and left behind this incredible fossil record.
Their story is a testament to, well, adaptability, isn't it? They spread across continents, evolved into such a variety of forms, and really made their mark in all these different ecosystems.
And that diversity is what makes them so fascinating, right? They weren't just one kind of predator. They ranged in size from something like a lynx to a lion, and they probably used all sorts of hunting techniques.
All those different forms as adaptations, it speaks to how powerful evolution can be, shaping life based on, well, whatever pressures it faces.
It really makes you wonder, what if they hadn't gone extinct? What would our world be like today with these false saber-toothed cats still around?
That is a fascinating thought, isn't it? It's hard to say for sure, but they probably would have continued to evolve, to diversify, maybe playing key roles in ecosystems all over the planet.
Can you imagine encountering a descendant of Barbara Felidae somewhere in the North American forests, or a modern-day Vampirictus darting through the undergrowth? It would definitely add a unique element to our planet's biodiversity.
No doubt about it. But their absence also makes you think about the impact of extinction, right? What role might they have played in shaping ecosystems if they had survived? What interactions, what connections have been lost because they're gone?
It reminds us that everything is connected, and extinction can have these ripple effects that we might not even realize. But even though they're extinct, Barbara Felidae, they still have these valuable lessons to teach us about evolution, ecology, even about how science works.
Their fossils are like this treasure trove of information, just waiting for us to unlock it. And as we continue to study them, to analyze them, we gain a deeper understanding, not just of them, but of the broader patterns that have shaped life on Earth.
So for anyone listening who's, well, captivated by these amazing creatures, what would you say are the most important things to take away from our deep dive into the world of Barbara Felidae?
I think the biggest takeaway is that studying the past, it's not just about digging up bones and teeth. It's about understanding the story of life, how it's changed over time, what forces have driven those changes.
Their story shows us that evolution is powerful, capable of creating incredible diversity, incredible adaptations.
It also highlights how important it is to keep asking questions, to keep researching. The fact that there's still debate about their classification, that's not a bad thing. It shows that scientific understanding is always growing, always evolving. New discoveries can challenge what we think we know and lead to new interpretations, new perspectives.
And maybe most importantly, Barbara Felidae remind us that the natural world is full of wonder and mystery. There's still so much we don't know about these creatures, and every new fossil we find has the potential to change everything.
Their story really is a testament to the power of curiosity, and to the importance of continuing to explore the past, to understand the present and the future.
Well said. It's been an incredible journey going back in time with these incredible creatures, the Barbara Felidae. We hope you've enjoyed this deep dive as much as we have.
And we encourage you to, well, keep exploring, keep that curiosity alive, because you never know what amazing discoveries are out there just waiting to be found. 631.